Hello, my name is Ria. My teammates are Tinh-Phong and Chelsea, and this is our educational game. We did a chemistry-themed Super Mario. The home screen has two buttons. There's an information button that shows map controls and level controls using the arrow keys and the objective of the game, which is to collect coins to get enough energy to create a reaction between solid potassium and gaseous diatomic chlorine, which is how those two elements appear in their natural forms. Clicking the play button will lead you to an animation. Typing Y will play the animation. Typing N will skip it. This shows a romantic attraction between the potassium and the chloride, mimicking the original Mario. And then there's the map. Each of our levels begin with an informational lesson in an effort to increase the educational aspect of our game. A good example of this is our level 4 game. So it shows the number of lives and then the world being entered. And so this level is all about the ionization of chlorine. So by pressing enter, we get first a chalkboard that defines ionization and then explains why ionization takes place. Then it prompts the user to look at the periodic table to see how many valence electrons chlorine has. And the answer to that is 7. And then once the correct answer is given, then the next prompt appears. And then it asks for the charge of the ion formed, which is -1. But for example, if I just put 1 as a wrong answer, it'll prompt me to keep trying. Or if I put 5, until I finally put the right answer of -1. And if I press enter, it takes me to the next slide. Then I have a chlorine atom here, a neutral one. Then I have a potassium ion, which was formed in a previous lesson. And then I have an extra electron that was lost in the ionization of potassium, which was lesson 2. Then it's asking me to drag this electron to the vacancy in the chlorine shell. So I can drag it everywhere until I get to the vacancy, in which point it locks, forming a Cl- ion. And that is explained here. And then it talks a little bit about the energy change associated with the addition of this electron, which is called electron affinity. And then it's asking for what that is, which was -349. And once you get that, it asks you to begin the level by pressing enter. This is an example of how we incorporated educational aspects into our game. In addition to keeping our game educational, we wanted to make sure we were still keeping it fun and relevant to the Mario themes. At the end of every lesson, we included a level. So for example, this is the end of lesson 3, and this is the level that accompanies it. So you can see you have different blocks that can give you power-ups and lives and different blocks. The goal of every level is to get to 10 coins because that's how it stays constant with the chemistry theme. And if not enough coins are collected, that means not enough energy has been collected in this level, which also means that not enough energy has been collected for that process of the level to occur, and that's why the level won't be cleared. You'll see different enemies in each of the levels, but in these ones we have these like spiky boxes, and this is the end of the level. There are 5 main steps in our reaction, but we have a 6th level, which is to check for understanding, which imitates Bowser's Castle. But the main thing is that there's not that many obstacles. Instead, we ask questions. So it says, for example, true or false, a solid substance cannot go directly from a solid to gas. So this is referring to that first process of sublimation. Therefore, it's false. And then it asks what the process is called, sublimation. And it says, is this process endothermic or exothermic? And it was endothermic. And once you answer all the questions correctly, you'll be able to continue moving on. And basically, there's 5 jumps, which you have 1 for every level. So if I do another example, in order to form a salt, an ionic compound of potassium must lose an electron. Suppose I type false, which is the incorrect answer. It'll keep asking me to try again, so then the answer must be true. Finally, now that I've reached the end of the level, if I just continue moving to the right, the world ends. And this is the ending animation showing the 2 gaseous ions that are now going to bond to form potassium chloride, which was the salt we were trying to form. And this is the ending screen, and if you press enter, it'll take you right back to home. Thank you for watching our screencast.